Okay, now we're going to work on how to predict products. So if we know our reactants, we're going to be able to predict products. So we're going to look at the type of reactions that take place and then figure out how the atoms are going to rearrange. So rules of formula writing always apply. So synthesis. So basically, if you have two elements, they will combine to form one compound. So what we're going to do is basically take our two elements from the reactant side and then put them together. We have Ca plus 2, so we're going to go back to our rules, and sulfur is -2, okay? So they're going to cancel, so you end up with CaF. So sulfur is S8, but now what we're going to do, we can rewrite that as Ca plus S8 makes CaF. And now we're going to balance it. So we have 8 sulfur, so I'm going to put 8 over here. So when I put that 8 there, that's going to make 8 calcium and 8 sulfur on my product side. But so now I have to fix my reactant side, and I'm balanced. So again, we have to put the elements together. This is plus, oxygen is -2. We crisscross our charges, that does not change. So it's Ag2O. So we have Ag plus O2 makes Ag2O. So we have 2 oxygen, so I'm going to have to put a 2 there, but that makes 4 silver, so I'm going to put a 4 there, and that should be balanced. All right, I'm going to erase this so I can make room for the next thing. So we have magnesium with a +2, and then we go chlorine -1. We crisscross it and it becomes MgCl2. So let's go back. So we get Mg plus Cl2 makes MgCl2. So it looks like we're already balanced. We have 1 magnesium on this side, 1 magnesium on that side, 2 chlorines on both sides. All right, so let's move on. Now we're going to do decomposition. Basically, decomposition is separating the two. So we have calcium and sulfur here. So we're going to separate it, calcium plus sulfur. So sulfur is S8 when it's by itself. So I can go back and balance this. So we're going to put an 8 there, which makes calcium have an 8. And now we're balanced. Okay, so H2O will decompose into hydrogen. That's because of the diatomic, not because of the charge, plus O2. O2 is actually oxygen, so diatomic again. So we have 2 oxygen here, so I need to put a 2 here to fix my oxygen. And then I put a 2 here to fix my hydrogen. Okay, sodium chloride breaks up into sodium plus Cl2. That Cl2 is because of our diatomics, Brinkelhoff. So we're going to put a 2 here to fix that and a 2 there. And now we're balanced. All right, single replacement. So if you have an element in a compound that reacts, single replacement, metal will replace metal, non-metal replaces non-metal. So when we're looking at this first one, this aluminum is going to kick out the sodium. So we're going to put aluminum +3 because we always have to go back to our charges. And then OH -1. It kicked out the sodium, so we have sodium with a +1. So this is going to crisscross. So we have AlOH3 plus sodium. So now I have to go back and balance the whole thing. So we're going to put a 3 there because we have 3 hydroxides. When I put the 3 there, it's going to make 3 sodiums. So now I'm balanced. Okay, I'm going to erase this so that we can have room for the next one. So chlorine, because it's an anion, is going to take the place of Br. So what's going to happen is we're going to do Na plus Cl minus plus, kicked out the bromine. We're going to put a 2 because that's a diatomic. So that goes away. So we've got a balance. We're going to go back and balance. So now we have 2 NaCl and Br2, but then I need to put a 2 here so that my Na and my Br are balanced. All right, combustion. We're going to always make CO2 plus gas, water gas. So that's pretty easy. The hard part is going to be balancing it. Those are the harder ones to do. So I have one carbon for hydrogen. I'm going to fix my hydrogen. When I did that, now I'm going to combine all these oxygens. So I have 4 oxygen. This 2 goes here and it also goes there. So we're going to put a 2 there. So now I'm balanced. We'll put gas here because it is steam. All right. So again, CO2 plus H2O gas. We have 3 carbons, so I'm going to put 3 here. We have 8 hydrogens, so I'm going to put 4 there. So now we got 6 oxygen plus 4 oxygen, which is 10. All I need to do is put a 5 here, and now I'm balanced. Okay, double replacement. So when we do double replacement, we're basically going to switch partners. So the plus is going to go with the negative there, and this plus is going to go with that negative there. So we're going to put it together. We don't lose our charges, so that charge of iron is plus 3. We know that from that compound. We put it with OH negative, plus we have K plus SO4 negative 2. So the 3 goes down here and the 2 goes down there. So we end up with Fe2 SO4 3 plus KOH makes FeOH3 plus K2SO4. All right, then we have to go back and balance it. So we have 3 sulfates. So I'm going to put a 3 here. Now I have 6 potassium, so I'm going to put a 6 there. When I did that, it made 6 hydroxides. So I'm going to put a 2 here. This was a 2, so I think now it's balanced. So we're good to go. I'm going to go ahead and write this. So we can do the next one. All right, so we get the charge of lead from here, okay? Pb plus 2, I negative 1, plus K, it's 1, NO3, negative 1, and that goes away. So this becomes PbI2 plus KNO3. All right, and then we need to balance this. So I think I'm running out of room. So let's see, if we put a 2 here, we're going to have to put a 2 there. And I think we're balanced. All right, move on to